Hello, algebra students. In Chapter 9, Section 4, we're going to learn how to solve quadratic equations by completing the square. These first three review problems I'm going to leave for you to attempt on your own. And I want to work the fourth review problem with you because it's a great lead-in to completing the square. Number 4, we're supposed to determine whether this trinomial is a perfect square trinomial. And if it is, let's factor it. To check for perfect squares, you take the square root of the first term and the square root of the last term. And if it's a perfect square, which 16 is, and of course x squared is, and the square root of 9 is 3, we have same sign, both negative. So to factor this trinomial, it would be 4x minus 3 times itself, making that a perfect square trinomial. Well, when we're solving quadratic equations, we can factor, which is what we just did with number 4. Even if it wasn't a perfect square, you know how to factor. We can, choice number 2, graph it to find its roots. And today we're going to learn a third way. This is our third method. It's called completing the square. And it's a third way to solving quadratic equations, okay? Completing the square. What that means is we're going to force a trinomial to be a perfect square. We can take any trinomial and make it a perfect square. We're going to work a little bit of magic. And no magic trick comes without practice and practice and practice. So this is going to sound a little bit crazy as I go through these 3 steps. But the more we practice, the easier these 3 steps will become second nature. So here is our first 2 terms of a trinomial. We have an x squared and we have a bx. By the way, your coefficient always needs to be 1, so if it's not a 1, you need to divide everything by the number in front of x squared. That's probably, we might should have had a little extra step there. Make sure your lead coefficient is 1. Step number 2, I'm going to call it, is to look for your b term and take half of b. So we're going to say b over 2, the coefficient of x divided by 2. Then the next step, after we've made sure our lead coefficient was 1, we've taken half of b, we're going to square the result of step 1. So b divided by 2, if we knew what b was, we'd have a number, but we don't have a number, so I have to just say b over 2, and we're going to square that term. Then your third step, or your last step, is to add the result of b over 2 squared to both sides of your equation, because we're going to be solving, so we're going to have it equals a number or equals 0. For this problem, they only gave us the first 2 terms. So once you know what b over 2 squared is, you're going to add it to both sides. And of course you have to do it to both sides because it's an equation, and whatever you do to one side of an equation, you must do to the other. Now this is very confusing. I remember the first time I heard about completing the square. So trust me, we're going to keep practicing and practicing until we get this. Let's find the value of c that would make this a perfect square trinomial. So our lead coefficient is already 1. The number in front of x is negative 12. So step number 1, we're going to take negative 12 and divide by 2, and that gives us a negative 6. Step number 2, we take negative 6 and we square it, which is of course going to give us a positive 36. And then our third step, we're going to take that, and since it's not an equation, we're looking for the value of c. The value of c should be a positive 36. Now if I wanted to check myself, is that a perfect square trinomial? How would I factor that? It would be x minus 6 squared. We made that a perfect square because the square root of 36 is 6 and the square root of x squared is x, and if you FOIL it out, it'll go right back to being that trinomial. Alright, I want you to try this one. Pause the video right here and see if you can figure out what C should be. And I want you to do step 1, step 2, step 3, just like I've modeled here. Alright, hopefully you also found the value of C is 49. And now that we know it's 49, let's make sure, could we factor this? X plus 7 squared. It is a perfect square trinomial. Isn't that amazing? It's like a little magic trick. Okay, flip the page, pause just a second, make sure you could list what are the 3 ways we now know to solve quadratic equations. I've already stated that once in this video. Okay, so our third way is completing the square. Now let's get busy learning how to do this. The very first one says solve by completing the square. Now we were trying to figure out what C should be in the first 2 examples. Now I have a number in the C position. What we want to always do is leave x squared and 6x on the left side of the equation. Go ahead and subtract 5 from both sides and make that 9 to the right of the equation. And notice how I'm going to leave a little blank here and here. So what are we going to add to both sides of the equation? That's where we have to complete the square. So come over to the left. Let's go through our steps. Take half of the number in front of x. So half of 6, which is 3. Step 2, square 3, which is 9. And now step 3, we're going to actually do over here in the problem where we add 9 to both sides. So on the left, we have x squared plus 6x plus 9, and that is a perfect square. That's x plus 3 squared. And on the right side of your equation, you have the number, 12 minus 5 is not 9. I'm sure y'all caught that. So that should have been a 7. So I've added 9 to both sides, and 7 plus 9 is 16. And now I'm ready to solve this equation. So stop right there for just a second. Let me review. Completing the square, I took my 5 over to the right and made 7. And now I'm ready to go through the steps of completing the square. Half of 6 is 3, 3 squared is 9, and that's the number you add to both sides. So now to solve this equation, we have to take the square root. Remember this? We did this a few months ago, seems like now, where we take the square root of both sides. We end up with x plus 3, and we're taking the square root. We have an x. We don't know if it was positive or negative 4, so you have to check for both the positive and the negative. So x equals negative 3 plus 4, or negative 3 minus 4, and that's going to be 1 and negative 7. Ladies and gentlemen, we have solved our trinomial, our quadratic equation. And what are these numbers? What are 1 and negative 7? That's not an ordered pair. That's not an x and a y. Those are our roots, where the quadratic passes through or crosses the x-axis. Okay, I'm going to pick a new color so I don't run into my other problem. I'm going to line this off in blue. And number 2, there's not a value to have to carry over. So I'm going to go ahead and rewrite my problem though and leave that nice space so that I know that I have got to complete the square. I remember that I'm adding something to both sides. What am I going to add to both sides? Step 1, take half of negative 2. When I take half of negative 2, I get negative 1. Step 2 is to square negative 1, so that's going to be 1. So what do I add to both sides? I add 1 to both sides. So this is a perfect square. It's x minus 1 squared. And on the right, I'll have 14 plus 5, which is 14 plus 1, which is 15. Now to solve, I need to take the square root of both sides. When I take the square root, I get x minus 1 equals a positive or negative square root of 15, which is not an even number. So it's going to be a non-integral root or my roots are not going to be integers. And so I will add 1 to both sides to solve for x. So 1 plus or minus the square root of 15 is the most accurate answer. Those are my two roots, the result of 1 plus the square root of 15 and the result of 1 minus the square root of 15. I'm not looking at the book. I'm not sure if they are going to actually give you the estimates. You remember how we were working on that on our calculator, how to come up with the most accurate estimate. Well, for this problem, to leave it in this form is actually a more accurate answer than to estimate to the nearest decimal. So this is a fine answer for me on any test. All right, I want to check your progress, so I do want you to try 3 and 4 on your own. I am going to work them out, but I'm not going to talk you through each step. I'm going to pause the recording right here, so you go ahead and pause and try 3 and 4, and then you can hit the play button to check your work. Okay, and so as I finish up number 3, I get 10 and negative 2. And for number 4, I get the result of 3 plus the square root of 7 and 3 minus the square root of 7. The next two are homework examples. I do expect you to try these two on your own without me. I will be looking to see that you've attempted 20 and 22 tomorrow. Now the next examples, our lead coefficient is not 1. And we need, remember I mentioned that the step number 1 really should be to check to make sure that your x squared value, the coefficient, is 1. So how do I make this 1? I'm going to divide everything by negative 2. Everything. Whatever you do to one side of an equation, you have to do to the other. So it's supposed to be dividing by negative 2. I think my negative didn't take. So that'll give me x squared minus 18x minus 5 equals, actually that's going to be a plus 5 because a negative divided by negative, and equals negative 12. And now to complete the square, I will subtract 5 from both sides, which will give us a negative 17. And now I'm ready to follow the steps required to completing the square. I went back and added the x. You'll notice I left off the x. So we're going to take half of the number in front of x. So half of 18 is 9, and 9 squared is 81. So I'm actually going to be adding 81 to both sides. So that results in x minus 9 squared equals 64. Take the square root of both sides, and x minus 9 equals plus or minus 8. So 9 plus 8 is 17, and 9 minus 8 is 1. So my roots are 17 and 1, and I'm doing some of that in my head, and the more you practice, the better you'll get at this also. For our next example, I have to divide everything by 2. Now you may need to pause and let it soak in what I've done. I've divided by 2, and I subtract 7 halves from both sides, and thankfully when I subtract 5 halves minus 7 halves, I have negative 2 over 2, which is negative 1. So now I'm ready to complete the square. Alright, so half of 1 is 1/2, squared is 1/4. Add that to both sides. To subtract here, I'll end up with negative 3/4. And now I'm ready to take the square root of both sides. Uh-oh, I can't take the square root of a negative. So this problem is not going to have any roots. It's going to be no solution or no real roots for your answer. I'm running out of time, so I'm going to ask you to read this word problem, maybe even read it twice on your own. Alright, so it told me r is rate, x is distance. At what distance? So that's my variable. I'm looking for distance at a rate of 5 miles per hour. So I plug in 5 for r. In order to complete the square, I need my lead coefficient to be 1. Alright, I divided everything by negative 0.01, which changed all of my signs but got rid of my decimals. I have a lead coefficient of 1. Now I'm ready to complete the square, taking half of negative 80, which is 40, and squaring it. And so we'll add 1600 to both sides. For the sake of time, I'm kind of working ahead of you. Now we're ready to take the square root of both. And beware that you can't have a negative distance. So we'll choose the positive answer, 73.7. Have a great day.